All right, so guys, I guess if there's any positive out of this is that as a 2-day section, there's actually not going to be any homework due tomorrow. Again, I would highly encourage you, as far as we're going to get, I do think that you're going to be able to do some of the assignment. So I obviously would encourage you to do what you can on the homework assignment, but again, not due until it's looking like Thursday. Both day 1 and day 2 are going to be due on Thursday. So just so you're aware, that's how that's going to go. But like I was saying a minute ago, guys, the better we understand ellipses in 10.3, the easier hyperbolas are going to be. Now, the reason for that, circles kind of, I feel like circles are sort of off on their own because we've studied circles very thoroughly in previous classes, okay? But the way that we talked about parabolas is conic sections, the way that we talked about ellipses, and then the way we're going to talk about hyperbolas. Day 1 is very specific to the physical attributes of that particular conic section. So we had to, again, even though we knew what a parabola was, we had to talk about, well, what's the vertex, what's the focus, what's the directrix, what's HK, what's P, we had to talk about all of that stuff. Same thing with the ellipse. We had to talk about, again, now more stuff, the center point, the vertices, the foci, the endpoints, blah, 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 blah. We had to try to wrap our mind around what all of that meant. So the good news, where we actually catch a break here, I suppose, with hyperbolas, is that all of those physical parts that we had to learn about within an ellipse, they're the exact same with hyperbolas. Okay? A hyperbola is going to have vertices. It's going to have a center point. It's going to have foci. Not exactly endpoints. We'll talk about that a little bit more specifically. Again, we don't really have eccentricity, but we're going to have asymptotes that we need to draw in. So again, just real quick sketch. If this is our ellipse, remember that we have our center point, we have our vertices, you have your foci, we have our endpoints, you have your major axis, your minor axis. All of that stuff is going to go. Same story here. We're going to have a center point. The big difference now is that my vertices and my foci are essentially flipped, meaning that my foci are going to be further away from center than the vertices. Because what we're doing is we're creating a shape that's going to look more like this. So I mentioned asymptotes a minute ago. The asymptotes are going to diagonally be put in place here and here. They're going to be the same in terms of the ratio, but one's positive, one's negative. That's how it's always going to work. So if, say, this is positive 4/3, this one's going to be negative 4/3. So again, you don't really have to find two different slopes. It's going to be plus or minus the slope, and it's all a ratio. A over B or B over A that we're going to be contending with. But guys, like I said, one of the spots to where I do feel like we can kind of speed things up is within hyperbolas. We already know all the parts. It's still the same story. We need to identify HK, A, B, and C. Once you have those, we're in great shape. And where we again catch a break is that the center is still HK. A is still the distance from center to vertex. C is still the distance from center to focus. B is a little bit different because they're not quote-unquote endpoints. But again, the way that we calculate B is the exact same way. So all of those parts, you're going to hear us multiple times today, and really more so tomorrow, saying just like with an ellipse, we do this. Or just like within an ellipse, it's going to be that. So like I said a minute ago, the better we understand ellipses, the better we feel, or the more confident we feel about section 10.3, the easier these things are, that our hyperbolas are going to go for us. All right? So the goals that we have in mind, students will be able to understand what a hyperbola is and, I suppose, and all of its physical parts. That's, even though we have a very limited amount of time, that's the part that hopefully we can walk out of here today feeling pretty confident with. Is let's know the physical pieces of the hyperbola. Number 2, students will be able to create and effectively use asymptotes to sketch the hyperbola. Again, more of a tomorrow thing. Number 3, students will be able to find the center, vertices, foci of a hyperbola. Again, I think we might get into bits and pieces of that today, but more so tomorrow again. And then number 4, students will be able to write equations of hyperbolas in standard form and graph. Again, definitely a tomorrow thing. All right, so where this all starts, just like it did with a parabola, just like it did with the ellipse, where it's going to start here with a hyperbola is how do you physically create a hyperbola? Like what is this all about? So the definition that we see up there, the set of all points x, y in a plane for which the absolute value of the difference of the distances from two distinct fixed points called the foci is constant. Now, that is almost identical to the definition that we had for an ellipse. one word, in fact, is going to be changed, and it's right here. We're finding the difference. So what we're saying is, how does this point, xy, how does that fit on the ellipse? Well, if I were to measure to this focus and measure to that focus, and now find the difference between those, subtract them, that's going to stay constant. Meaning if I were on this point, this distance minus that distance, this distance minus that distance. Up here, that distance minus that distance. That's how you physically create the ellipse. Okay? Can somebody remind me, please? I said ellipse. I meant hyperbola. That's how you physically create the hyperbola. What would it have been if we were finding an ellipse? We were going to find the difference. What we're going to find? We're going to find the sum. You're going to add them together. That's how you got the ellipse. If you subtract them, that's how you get the hyperbola. Does that make sense? So I know it looks like we've got a lot of stuff going on. We do have a lot of stuff going on, but this is the actual hyperbola. These curves. Okay? Now from there, we're going to have the center point, smack dab in the middle. We're going to have the vertices, located here and here. We're going to have the foci, located here and here. Then we're going to have this value for b. It doesn't really lead to anything, but it's going to help us to create our slopes of the asymptotes. And like I said, we're going to talk about that a whole lot more tomorrow as I'm looking at the time that we have remaining. Okay? So the other thing we want to point out here is we do have a couple of other changes. Unfortunately, it's not a complete everything that we used it with ellipses we'll use with hyperbolas. Unfortunately, we can't use that or can't pull that off. But we refer to what we call the transverse axis. It's going to be a line segment that's connecting the vertices. It's a line that passes through the foci, vertices, and center. So this right here is the transverse axis. The reason a textbook would define a transverse axis is now we can say if the transverse axis is horizontal, then we have a horizontal hyperbola. You probably would have assumed that it's horizontal because it opens left and right. That would have been a very safe assumption. Okay, but if this were an ellipse, I guess what is the ellipse version of what we're calling now a transverse axis? We had an axis. We didn't call it the transverse axis. What did we call the axis that went from vertex to vertex? That was called the major axis. All right, now here's the reason why. With ellipses, we had the major axis, you had the minor axis. Major is always bigger than minor. Within a hyperbola, it is very possible that A is smaller than B. It's very possible that that's going to happen, which if we're still playing by the same rules, calling it major and minor, that would mean that the minor axis is bigger than the major axis. That's just too weird for us to fathom, so instead we change the names. We don't call them major and minor, we call it the transverse axis, which is vertex to vertex, and then we're going to have what we call the conjugate axis, which is perpendicular to the major axis. Okay, we'll talk about that a little bit more as we go here. But the center point, it's still going to be the midpoint between the vertices or the midpoint between the foci. What we need to know is variable-wise, it's still HK. Okay, center point's going to be HK. All right, so guys, real quick, I know that we don't have a lot of time, but I definitely wanted to get through this slide. We've got a couple of things that I want you guys to do just with the people around you. Okay, but I do seriously want you to actually talk this out and figure this out with a group. What you see up here are the two standard forms. On the left, we have the horizontal. On the right, we have the vertical. So the first question that I want you guys to answer amongst yourselves is, how does the hyperbola equation differ from the ellipse equation? Okay? I'm going to pause this here. You guys go ahead and talk that. All right, I think we got it. Kylie, you said you got this. What do you got?
With ellipsis, the denominator changes between horizontal and vertical, but with the hyperbola, the numerator does. And we're subtracting now.
True. I like the second thing you said more than the first. And it's not that the first was incorrect, but initially, if you guys didn't hear back there, Kylie was talking about with an ellipse, the denominator switch. With hyperbola, it looks like the numerator switch. Absolutely true. But I really like the second part. I think that's going to be simpler. She said, oh, we're subtracting. So would you agree that if we merely switch that from subtraction to addition, that would change it just to be an ellipse? Absolutely would. Okay, so that's the main thing that we want you to focus on. Now think about the reason just for a second as to why that is. How did we define an ellipse? We said that, all right, any point on the edge of the ellipse, find the distance to the two foci and add them together. With the hyperbola, find the distance and subtract them. That's why we have the addition and the subtraction stuff. All right, so guys, the second thing we wanted you to do real quick before the bell rings, within the hyperbola equations, what's the difference between the horizontal and the vertical? talk it out with your group, see if we can't figure that out. Here's where we'd like to focus a little bit more on what Kylie said initially. All right, so guys, here's the deal, and I know I'm probably leading a little too much, but the bell's gonna ring any second. Now, when you're squaring, we know everything's positive, right? Give me a second here. We know things are gonna be positive. So if you have a subtraction problem, do we agree we have a positive minus something? So you have positive and negative now. If your x squared is positive, it's horizontal. If your y squared is positive, then it's gonna be vertical. If that doesn't make sense, we're gonna talk about that a whole lot more tomorrow. Guys, have a great day.